Welcome, everybody. We are pleased to have you on board to answer the simple question, how can we manage from DevOps point of view, the fact that on one side we have source code to deploy, but also on the other side, infrastructure to deploy, and all of that with the governance layer on top. I'm John Wagner, I'm SEs from France, and I have with me today, Dennis, SEs from Switzerland. And Dennis, can you give us a bit of your background, please?
Yes, of course, Julian. So I'm Dennis Kuipers. I'm based in Switzerland, original Dutch, and work now 2 years for ServiceNow. Before that, I was working 12 years for Credit Suisse as an IT operations architect, specialized in monitoring, event management, automation, everything basically what has to do with IT operation management. Before Credit Suisse, I was working for companies like Veritas, Semantic, Precise, and so on. So a lot of experience in the let's say the monitoring space, but also in the automation space.
All right, cool, thank you. And I'm also with Dimitri today.
I'm Dimitri Finas. I joined ServiceNow as part of the Swiggle acquisition. So I was acting as an architect, a technical architect in Swiggle. And I'm based in Paris, as you can see behind me.
All right, thank you.
People France.
All right, Dennis, shall we give the stage to you?
All right, so let's start. What we're going to show today is an integration between what we call the pipeline and the ServiceNow platform that's basically managing the pipeline from a governance point of view. In this example, I will show you how this can work as infrastructure as code with automated governance, as we call it. So today we will have different technologies involved in this demo. We will see Jenkins, we will see Terraform, of course the ServiceNow platform in its full extent. We will see some coding, we will see a lot of things today. So it's going to be a very exciting demo, end-to-end. And of course, the focus will be around the pipeline, but I will also show you today how that can be, let's say, integrated with things like ITOM, event management, discovery, and so on. So we will have a lot of components in this demo, and this is basically what we're going to do. So as you can see, we have the use case here, and the use case is that we have a pipeline which using coding application that is being built through Jenkins. Jenkins will then create the artifact, and the artifact will then be deployed on the cloud infrastructure. So if you look at how this has been done in a lot of companies, they probably will go straight into the Terraforms or the Ansibles to deploy that artifact on the new cloud infrastructure. Of course, you can do that. There's only one thing. How many controls do you have in place that really make sure that things are being traceable, auditable, and from a security point of view, also kind of secure enough to be deployed. And those are the things that basically is missing in a lot of cases. So what we will show you today is that we will bring in those controls to make sure that if we're going to do a deployment, that our deployments are secure enough. They have all the necessary controls. They have been checked against different validation engines. They will have an automated change approval. And of course, we make sure that everything is according to budgets and quotas. So today we will have Swiggle, we will have DevOps, we will have CMP, cloud management. We will also have GRC being in part of it. And the last one is, of course, ITOM in visibility and health. So that will be the demo, and we will show you how that works. The reason why we do this demo is because, as I mentioned, there's a lot of deployments going on, but how many of those deployments does have the controls in place to make sure that those deployments are secure enough? All right, so having said that, then we can go into the demo. So I will start with the tool chain. I will start on the left upper corner as a developer. The purpose of this whole concept is that we will say that developers should work in their own environment. So they should not be bothered with too much governance, because that's always kind of things that, first of all, they don't like it. Second, it takes a lot of time to fulfill all those different paperwork, and they want to be really focused on what they like to do, and that's developing. So the developer will basically work only in his environment. The rest, all the other interfaces to the governance part of this demo is done through APIs. So there will be no portals involved. Everything will be connected through APIs. Okay, so let's start as a developer. Me as a developer, I will change some code. And of course, the most popular one are the Eclipse and the IntelliJs. So here I have my corporate website where I have all my code stuff. And what I can do now is do some code changes. So if I go to source and I will go to my JSP, I will just do a very simple change on my code in this index JSP, where I can, this is where I can add some text. So this is a second test, and this is for a great demo, which I can add for a great demo. Okay. So I changed my code, and as you can see, there's in my version control, there are 4 files that has been touched during my absence or during my changes. And that's something that I like to commit to my repository. So what I can do now is a commit. That means that the commit will be now pushed to my repository, which is in this case is GitLab. So normally a good exercise from DevSecOps point of view and from a DevOps point of view is that you commit always a message. In my case, I will add the work item to this message. The reason for that is that I like to associate my story to a commit, so that I can basically trace back what I have deployed in production. So that means that if I deploy my code in production, I know exactly which stories are being associated with that. So that's why I always commit with a work item. And that makes it also possible for ServiceNow to correlate the commit with the work items. So that's the reason why I'm doing this. All right, so before I commit, I can explain how it works. So this will be pushed through GitLab, and from GitLab, it will be pushed through ServiceNow through a webhook. So that means all my commits that I'm doing as a developer will be automatically pushed to ServiceNow as well. It's not only to the repository, but also to ServiceNow. So let's do that. I commit and push. So confirm, push. So as you can see, when I switch screens, and I will go to my ServiceNow instance, then you can see that the commit has arrived. When I go to the commits here, this is part of the DevOps application, as you can see. So in the DevOps, you have different configurations things. But here, as you can see here, I have all my commits. And this is the commit I just done. So today is the 3rd of November. And this is the commit, and this is the work item that I'm working on. Now, the work item can come from ITBM Agile or from any other planning tool. In this case, I'm working with Jira. So same as my repository. In Jira, we also have a webhook. So as soon as I created a story, then that story is automatically pushed to the DevOps module, not to the ITBM Agile module, but to the DevOps module. And this is where the places that will arrive in the work items. So here I have all the work items that I receive from the planning tools. Now, when I receive the commits, there's a kind of a process running in the background that associates the work item automatically with the commit. And that's something that we will see back later on in the demo. So what I have here is basically my first integration. I have my commits and I have a work item associated together. So if this is going to be deployed to any stage, to a UT state or production stage, I'm always able to see what I have deployed. And that's a very, very important thing for DevOps.
Quick question. What is the role we should be able to have that view? I'm guessing that's not the developer that will go into ServiceNow looking for the commit, right?
Good question. So, of course, this is not a developer that will go into ServiceNow and will check this. So this is basically kind of metadata that we're going to use for change management later on.
Right.
This can be used by the change management owner or the change management manager, because here you can have more insight into what kind of change has been going through his process. So what kind of changes, and that's something that's the traceability that I was talking about. So here, basically already kind of, in a kind of a change management role. But the developer, of course, is not ready yet. So the next step, when he pushes his code or commit his code, he like to build his application. And for doing that, I will switch over to Jenkins, where I have my pipeline. So the pipeline, in this case, I'm using Jenkins, but of course we will support Azure and we support GitLab as well. So how does this thing work? When I do my commit in GitLab, then it can be the case that Jenkins will be automatically triggered to start a new build. But I'm not doing it, I do it manually, because here in this pipeline, I'm not only building code, as you can see, but I do also creating new infrastructure. So, and that's where the infrastructure as code comes into place, because it's kind of a common practice nowadays to build new infrastructure where you're doing deployments. And this is something that we can support with our cloud management module, where we have our catalog items available for the developers, where they can create automatically their new infrastructure through this catalog item using APIs. In the background, we have Terraform connected to the cloud management module, which basically doing the build of the new infrastructure in the Azure cloud. So that's basically the pipeline. A very important thing is the check config. This is the integration with Swiggle. So before I do any deployment, I want to make sure that I have the right configuration files, that my configuration files has been validated for different reasons. And my colleague Dimitris will explain everything about that later on. But this is the integration that I'm using to make sure that my configuration files are right and validated. Of course, I have my test phase. And between the deployment of my new prod infrastructure, I'm going to raise a change request to deploy my application. So between these two stages, there's an automatic change request coming in. So how does it work to get this information from Jenkins into ServiceNow? To make it work, this is an example for Jenkins, of course, but for Azure and GitLab, it's more or less the same idea. When I go to my scripted pipeline, you can see different functions, and this is basically the plugin that you need to install in Jenkins for ServiceNow. So here you can see the first kind of function, which basically sends the information from this stage, and this stage is the preparation of the Kafka client, to ServiceNow. So as soon as this stage will be executed, this information is also sent to ServiceNow. When I scroll down a little bit, and I will go into the check config, and here you can see how that will integrate with the Swiggle. Swiggle does have its own plugin as well. And this is the Swiggle integration. So also here we can see the ServiceNow step, but here I'm calling Swiggle to do the validation of my configuration file. When I scroll down a little bit down to the deployment of my application, I can see where the change request will kick in, and that's exactly here. So the plugin will give you some functions to let's say to inject your pipeline, and to make sure that the information from the pipeline is being sent over to ServiceNow. Good. So everything is in place to trigger this build. So let's do that. So as I mentioned, there are different phases and different stages. So every stage will be sent to ServiceNow, and this, of course, we can use in our change request, which I'm going to explain later. Okay, so let's start. This build will take some while because the build of my infrastructure, which I'm going to show you later how it works, going to take approximately 5 minutes. And I think this is a great time to switch over to Swiggle as soon as it reaches the check config phase to see a little bit more about Swiggle. So, Dimitris.
Yes, Dennis, thank you very much. So I will share some slide so that we can define what is Swiggle and what is the value of Swiggle inside this pipeline. Okay, so first let's define, when we are speaking about Swiggle, we're speaking about configuration data management, and we should define what we do with config data and what is config data exactly. For us, config data is any parameter or value that is used in order to personalize your application or your IT infrastructure. So it could be an API key, an URL, a username, passwords, feature toggles also. Anything like this could be used. And as you can see, when you deploy a virtual machine, most of the time you will use 20, 50 parameters in order to define this virtual machine. But at the end, if you look at the VM itself, it will contain hundreds or several thousand parameters just with any patch level of any library that is installed, list of administrators. So that's all these parameters that we are able to manage with ServiceNow Swiggle. So it could be application linked, release linked, environments, or infrastructure parameters. And what is important is the current situation is that these parameters are spread everywhere. Some of the parameters more linked to the application are mostly on the Git systems. Some parameters are in your CMDB. Some parameters are in other referential. So we try to collect all of this data that is important to validate consistency and validate that it is adequate before deployment. So how we do this? So if I look at high level, we will try to manage all this configuration, collect them, centralize them, check them. We will secure them also, because when you're on regulated market or where you want to avoid attacks from hackers or even errors from the inside, from people, you want to secure what is sensitive. You want to encrypt some values. You want to keep role-based access control based on the duty of everybody. And at the end, you want to validate compliance. The problem is you want to do this, but with speed, because you want to get the control, but you don't want to slow down your developers. You don't want to slow down your business and your applications for deployment. That's why we integrate to pipelines. So the purpose here is to do all these tasks inside the pipelines in automated way in a few seconds. Purpose is to get speed with control. And that's what we will do with Swiggle. As I said, we can do it for any kind of parameters, and we can do it across the full life cycle of your parameters. Meaning we will take into account all the parameters, the future parameters that are in Git for the next release, but we can also discover all the values that are currently deployed. In this use case, the purpose is to be able to manage deviation, ensure that nobody has deployed something that is incorrect comparing to your enterprise standards. Ensure that DRP sites are correctly configured, your primary site versus your backup site, and ensure that everything new that is deployed in your pipeline is correctly validated before deployment. What are the benefits of this? I would say that the best example to give you the benefits is to take customer example. And here you've got an example of a customer moving to cloud, to Microsoft Azure, to be a little more precise. And what they were searching for is they were searching for something that ensures their compliance, enterprise compliance, but also that will ensure secure data for all their sensitive values. And it would be agnostic from any cloud provider and any cloud solution. Why is that? Because for the moment, they are going to Microsoft Azure, but they are sure that in few months, they will go and they will split their infrastructure between many clouds, meaning they will have an hybrid and multi-cloud target. So they need an agnostic solution, and that's why they use Swiggle as a vault for their sensitive data, but they use also the compliance and validation rules as a control tower in all their deployment pipeline. At the end, they are building with Swiggle a source of truth for all the variables and values that are deployed on their cloud. And as we've got some capabilities to audit and track all change, it is building also an evidence repository in case they've got an audit, in case security officer wants to check something, or just in case some operational team wants to compare what has been deployed last 2 weeks because they've got an issue in production. At the end, all this has a business benefit, and the business benefit is first time right. If you avoid rework, if you avoid errors, you reduce your cost and you go faster to production. Let's take a look at how it is displayed and how you can control it. So this is a GUI mode. So it is a web interface where you can check everything that is happening. But at the end, what will Dennis show you is that everything is integrated. It means the purpose is not that you go in this GUI. The purpose is that you got the error directly in your pipeline, directly in ServiceNow, that you create automatically incidents or change requests. So nobody has to go here except the Swiggle administrator. Most of the user will find the information directly in their user interface. In Swiggle, what they could see is a data model. And here is the data model for a typical application where you've got an application with these different environments. And for each environment, you've got the infrastructure that this environment is using. And for example, here, I can see that this environment for this application is using 2 virtual machines. And for these 2 virtual machines, you can see that the infrastructure that I'm using here is a shortcut to my infrastructure model. Also, this model is built automatically when you import or collect information from your pipeline. So it is a dynamic CMDB, not a CMDB that is put manually by people, but really collecting data directly from your inputs, your pipeline. So it is building and building again and again based on the latest information. And what you can see about this virtual machine in particular is that it is shared between a lot of different applications and environments, meaning at the end that if somebody is trying to update a value here through an upload or through the GUI, if I change my HTTP setting, automatically the compliance rule will check the configuration for this virtual machine, but it will check also the configuration for all these applications and environments to see if it is still consistent and if enabling the HTTP firewall is okay for Web Portal 2, 3, 4, and all the other environments. At the end, the result of the rules will be available through a dashboard like here, where you can see everything that has gone good or wrong. So here is the evolution of my configuration, with each point being a picture, a snapshot of your configuration, meaning an unalterable picture for traceability, auditability, and also the result of the rules here with the different rules that you have assigned for this configuration, like for example here, a comparator rule between environments to be sure that you don't reproduce in your pre-prod environment the same settings and in qualification. And here there is an error because one value is the same, which is an URL value. But also you can have some security rules, like here, this DB compliance check that you have enabled security for this connection DB. So all these kind of rules could be controlled on the fly when you deploy. You will get the result in this dashboard for the Swiggle admin and for traceability, but you will get also the result directly on your pipeline, like Dennis will show you.
Yes, so I'm really depending on Swiggle because it's very important to deploy the right configuration files, not only from from an error point of view. I mean, we know that a lot of outages are caused by the wrong configuration files, wrong passwords, or the wrong user IDs. maybe the wrong environments, that kind of stuff. So it's very important to make that part of your pipeline. So what we have seen so far from a control point of view is actually the Swiggle part, the configuration part. So as you can see, my pipeline has been done, and as you can see, everything is green except for the config part, which I'm gonna explain you right now. Because when I go to my pipeline details, as you can see, I have my Swiggle validation report here, which tells me that I'm using HTTP instead of HTTPS. So those are the things that Swiggle can tell you, if something is not properly configured. This report I can use now for, let's say, in ServiceNow into my change request, which we're going to show you later how that can work. But this is already kind of the first kind of confidence check that we're doing. So the first confidence check is now the Swiggle part, the configuration part. So let's go back to the pipeline. So yeah, so the pipeline has been done successfully. Everything is green, so that looks good. So what happens after the config? Of course, there's some testing has to be done. And of course, it has built up the new infrastructure, and it has deployed the application. And in between, it basically automated the whole change request with auto approvals. So that's something that we're going to show you a little bit more in details how that works. So first thing that I like to show you is the information from the pipeline in ServiceNow. So when I go back to my ServiceNow instance and I go to pipeline executions, then I can see that my pipeline execution has been executed. As you can see, I can see the number of steps. I can see that the test passing is 88%. And that's because we will take into account the test results from the JUnit. So when I go into the pipeline, then I can see the details of the pipeline in ServiceNow as well. So I will have the same view as in Jenkins, but as you can see here, it's a little bit more enriched. So you can see, first of all the different unit tests. So I can see the unit test of my Kafka client. I can see the unit test of my corpus site. I can see the unit test of my check config, which is 50%. We continue with our pipeline for the demo's purpose, but this, of course, can, let's say, stop the pipeline saying, hey, your configuration is not right, fix it first and then do it again, right? So, but for demo purpose, we will let the pipeline going on. And then, of course, the UAT testing, which is 100%. So all my JUnit tests are done successfully. My check config part, which is the Swiggle part, is 50%, and that's because, as I show you in the pipeline, that the HTTP is configured instead of HTTPS. Why does JUnit, but this Swiggle thing shows up as a JUnit? Because we have a kind of integration there with Swiggle to show up as a JUnit in ServiceNow. But of course, when we have Swiggle onboarded on the platform, this will look a little bit different. Good, so when I scroll a little bit down to the right, then you can see that the whole pipeline is there, and at every stage of my pipeline is green, which is good. And here you can see the change. So it did do the deployment of my infrastructure, and there you can see here the deployment of my application is being successful. So when I look into the change, you will see a normal change, of course, with the out-of-the-box change, normal change request. But as soon as I will scroll down, you will see a little bit more details about the change itself. So here we have the typical change request stuff. Here we can see that some of the fields are being auto filled in, but that's something that you can change. But here, when I go down, then I can see all the things that comes from the pipeline. So for instance, I can see all the test results of my JUnits. And here I will have my JUnit test from the Swiggle point of view. So here I can see that the no HTTP has been done not successfully because it's using the wrong HTTPS. So I mean, it's not using HTTPS, but using HTTP. And here you can see that the password checker is basically successfully. That means that there's no passwords in plain text. So all the passwords in the configuration files are encrypted. Here I will see some other unit tests from my corpus websites, which are all done successfully. So this is already included in the change request. So as a change management owner or change management process owner, this is already great because this already gives me some good insight in the change and if they fulfill all the different policies. And of course, some of the most of the change policies are related to test, and they should be 100%, right? So the test results should be at least from a percentage point of view successful. Then, of course, I have included all the commits that are being part of the build. So here I can see what kind of code changes are being part of this change request. And this is something great because this is not only from an audit point of view, but maybe also later on from a troubleshooting point of view. Here I have my change policy that tells me, what kind of decision that I took for this change request. So in this case, it will be an auto approval because I have all the policies met. So that's great. There's more. There's of course the work item. So also the justification of this change is in here. So if I want to see what kind of change it is, I only have to click on this link and I will have all the details of that particular change. Of course, then the normal stuff, the affected CI, the impact services, and so on. So as you can see, there's a lot of information in this change request. So if I have to prove something from, okay, has this been deployed? Then what I have to do is to go to this change and open this change, so I have all the information. So from a traceability and from an auditability point of view, this is really great. Okay, so as I said, this is basically the change request between the deployment of the infrastructure and the deployment of the application. Now, as I mentioned, the pipeline also took care of the deployment of the infrastructure, which is basically an API call to our catalog item in the CMDP module. So when I go to the cloud portal, then you can see that my new infrastructure has been built. This is the recent stack that has been built. As you can see, it's been created 18 minutes ago. So when I click on the details, then I can see all the details of this stack. Let me see, where are the details? Yeah, here. So in this view dependency, I see, first of all the parts of this stack, what kind of components has been created. But more important, as you can see, the stack has been built on the Azure cloud infrastructure, but in the same time, it sends the information back to our instance. So our CMDB is automatically populated with the new stack that has been deployed. So that means I don't have to do manually changes in my CMDB, but it's all automated. It's basically integrated. So I have the full information of this new stack. And as you can see, it has created the filter machine, and it creates also a new application service, which my new application has been deployed to. So if I go to my Azure environment, and I will go to my resource groups, and I have to refresh, then you can see that a new resource group has been created, which is then 2097. If I go in there, then I can see all the different components that has been created. So to see if my change from the beginning has worked, so that is the change that I have done here. Let me highlight it. This is the wrong one. Window. I have to go here. So this is the change that I have done. So let's check if it's there, just by clicking on this one here, which is the application service. And then the application service does have an URL. It's this one here. So let's click on it. and let's see how the website looks like. So what I have done in this case, of course, the Terraform has built the new infrastructure, but deployment has been done through, in this case, through Jenkins, but it can be also done by Playbook Enhanceable, for instance. Now, as you can see here, the for create demo shows up on the new website. So perfect. So that has been done successfully. My new application is there. It runs on the new infrastructure, as you can see here, which is the Azure application service. But it also has created the VM where my kind of Kafka client runs. So everything is there. That means that my build has been done successfully. Everything is green, so I'm happy. Now, for kind of feedback into the tool chain, what I have done is basically integrated also with the Jira, so I can notify the developer that when I go to the story that is involved in this demo, that I can say your deployment has gone successfully. So the feedback into the tool chain is also supported from here. Of course, when something is failing, I can also send some information back to the developer in his environment, let's say tool of choice, where I can say, hey, your deployment has failed. This is an incident ticket which is assigned to it. Here are your details from Jenkins, and please, solve the problem. So that's something that we can also send back because we have the Jira spoke, which can be triggered at the moment one of the stages is failing, which I can show you later. Okay, so as I said, the application has been deployed successfully. We have seen that, but how does it work from a change management point of view? Because as you can see here, we have all the information. It has been auto-approved. So how does it work? For showing that, I go to the change policy. And in the change policy, which is basically a functionality of the change management module, is where I can define my change policies. So in this case, I have different ones, and I have used this one in the demo, the DevOps change policy quick start. And in this policy, I can bring in some inputs, and those inputs is basically the data that's available on the platform. Now, with our integration from DevOps, we can pull in the data from the tool chain. We can pull in the data from Swiggle, but we can also leverage the data from the modules like GRC or any other module that we like to use for making the decision if we're going to do an auto deployment. So in this case, we can see some different things. The top one is here the number of outages from the last month. So if I want to deploy an application and I know that there were many outages in the last month, then maybe I don't want to do an auto deployment. I maybe want to do a review first. So that can be used. And this information comes, of course, from outages, from the outage table. And this is, of course, ITSM. This is, of course, a typical example of the leveraging data from the tool chain, so the number of line chains. So if I have only 5 lines of code chains, then the risk of something goes wrong is not that high. So I can do an auto approval. But if I talk about 1,000 lines of code chains, that's a different story. In that case, maybe I want to do a review, or I do want to do a CAT meeting first. This is the one that is kind of DevOps practice, where I don't allow any deployments where the commit doesn't have a work item. And here's where the traceability comes into place. I want to know what I'm deploying, not only from a planning tool point of view, but I like to know also what I'm really deploying in production. And that's something that is very important. So any commit without a work item, I should not accept. And then, of course, the different stages will be green, which is basically normal. So the whole pipeline should be green, including the testing. And here's where I'm gonna bring in the GRC module. So I'm gonna check for vulnerabilities. Because with this application,
just a quick one on that one.
Yeah.
So basically, I'm guessing if that policy is made to auto-approve based on certain criteria, a change, I'm guessing we could also include criteria such as change maintenance periods or backup windows, stuff like that, right?
That's automatically already included because it's part of the flow. So if the flow runs, it will also take into account those kind of things. So the black windows, conflicts, stuff, and so on. So yes.
All right.
And we can make it even complicated, right? So let's say that if I going to deploy over 50 CIs, which is kind of a lot of CIs at the same time, which of course that's a higher risk. So in that case, also maybe you don't want to do an auto deployment, but say, hey, let's do a review first, because deployment of one CI, okay, what can be the impact, right? Now, so as you can see of these examples, we bring every data that's available from the platform in this decision model, right? So we can make it complicated as we want. We can bring any policy from any type of corner, right? And this is the corner from the security where I have some controls in place to make sure that my application is secure enough. So as you can see, I do some vulnerability scanning with Veracode, for instance. So I want to make sure that if I do a deployment, that my code is, first of all, is being scanned and there's no vulnerabilities is found. There are some application separation of maintenance sessions. So all those controls that basically is a different process, I can bring in as input in this change management. So here is where the GRC module can play an important role in the deployment. So if the controls are not being met or they are not compliant, then I can stop this deployment because let's fix the compliance first. So this is the integration with the GRC module, as you can see. Good. So go back to the policy, right? So again, we can bring any type of data that's available on the platform. And of course, the CMDB is playing a big part because the CMDB gives me all the relations between the CIs. So I can do some impact analysis and so on. So when all this policy is being set, then of course I can work on the decision model. So if all my policies are met, right, then I can give you an auto approval. And of course, this is something that you can filter. This is just an example, of course, but this looks like, test results should be more than 70, number of line of change code should not more than 25, a commit without a work item should be 0, and number of outages from last month should not be more than 2, right? So if those policies are met, then I can go for an auto approval. But of course, if I have not fulfilled my compliance, then maybe I want to do a cap approval, right? So here you can play around with your policy. So this is kind of the second line of defense, or the third line of defense. So we have seen Swiggle from a configuration point of view. We have seen the deployment of the infrastructure, which goes through the CMP, where we can check against quotas, we can check against infrastructure policies and budgets and stuff. So we make sure that that is also covered. And this is basically the third line of defense where we check against the different policies from a change management point of view. Actually, the fourth one we also show is the security one, because this is what these controls are doing for us. So we're bringing here the controls from security into the change management model. So we have now 4 lines of defense to make sure that our deployments are being successful. Okay, so that's cool. Now, how does it work from a flow point of view? As you can see here, this is the flow that is responsible for managing the change request. So it got triggered when the category is DevOps, and then it will follow this this path here. As you can see here, it picks up the policy data. So the policy data, as I mentioned, comes from the platform. Some of the policy data can be easily queried against the table. Maybe some of the policy data you need to kind of process in JavaScript. So that's where the actions items are coming to place. But when the policy data are being picked up from the platform, then we can look at the decisions. and then make the right decision based on this data. So as you can see, this whole process is fully automated. So me as a developer, I'm still working in tools like the Jira's, the Jenkins, the IntelliJ or the Eclipse. I don't have to go to ServiceNow to fulfill my work, because I want to say the boring part is taken care, but it will definitely do all the check-ins for me. So normally I have to go to maybe to an infrastructure team or to the CAP meeting where I have to discuss those things. But now everything is automated because I have the data on the same platform, which I can leverage to make the decision. So as I mentioned, I had 4 lines of defense. I have Swiggle for configuration management. I have the infrastructure CMP for quotas and for budgets and for infrastructure policies. I have change management where I can leverage the whole platform data to make the right decision. And of course, there's GRC, which I can bring in for the security part. So all those things being automated, and again, the developer doesn't have to go to ServiceNow to copy paste data and fill out some nasty forms. Cool. So this is the flow, and of course, at the end, it will feed it back to Jenkins in this case to say, hey, your change has been approved. Go ahead with the deployment. Now, I can imagine that during the pipeline, something is failing, the infrastructure is not successfully or whatever. Then, of course, this pipeline will be stopped. If the change request cannot be approved, the pipeline will be stopped. If people say, hey, you're not fulfilling all my validation rules, the pipeline will be stopped. Now, how do we feedback that into the pipeline again? Because we like to do that automatically as well. And for that case, I created a kind of a flow where it checks basically the stages of the pipeline. So if one of the pipelines, as we have seen here, not being successfully or green, then that flow got triggered. So anything that occurs here, that particular pipeline flow will be triggered. So let's have a look what it's doing. When I go to the flow here, so as you can see here, this is the condition where this flow got triggered, and it's definitely the case when the stage is not in the successful state. So the first thing it does, it will create a task. In this case, it's an incident ticket. Now, what it will do, it will go to Jenkins and get the console output. So it will update the created incident ticket with the output from the console from Jenkins. So there's some kind of information for troubleshooting in there. So me as a developer, I have in my incident ticket already some information about the issue. But what I can do now is, because we have Jira's and we have commits on the platform, we can sort out who's responsible for that. So what I will do next is to look up that particular Jira ID that is part of that build, or the story ID, and then send the information back to the Jira ID. So the developer will then have his incident tickets and the console output in his Jira story. So he will see that right away. He doesn't have to go to ServiceNow or some other tool to see, hey, the deployment has failed, because that's now basically automated. So here's what we have to call the feedback into the tool chain. So this is what happened when the deployment fails. But suppose that the deployment has done successfully, but still there could be an issue with the code, because it starts generating some issues. So as you can see here, this is the application what we're talking about, and what we want to see is everything is green. So after deployment, it looks like green. Me as an operational person, application support looks okay, good deployment, nothing happens, but still, it could be also after deployment, it could be some issues. And that's something that we can also kind of correlate to the deployment, because as soon as we start getting the alerts in, for instance, I have to just give me a sec.
Yeah, sure. Just a quick question.
Yeah.
how did you get these service topology right here? Is it because of the tag-based mapping, or is it?
Yeah.
Yeah.
So what I do, this is a special service mapping pattern that I'm using for Kafka, because as I mentioned, I deploy Kafka. So this is basically service mapping, where I map basically the whole infrastructure that I have created. So after the deployment, I'm going to run automatically a discovering process that builds up this picture for me. Remember that we saw this other picture here in this picture here. So this is, of course, the CMDB. This is not the service. This is the, I call it the dependency view.
Sure.
And this is basically the topology map from the application itself. So what I do after deployment, I'm going to rerun this process automatically from Jenkins that basically updates my whole new service map. And as you can see, after deployment, I see that there's an alert coming in. And that alert tells me that I have my CPU usage exceeded by 89%. So when this happened, and I'm responsible for this application, then the first thing is try to understand where this is coming from. So as you can see, I have different buttons here, which can help me to troubleshoot. One of the things that I can look at is the changes in this environment. So as I mentioned, after the deployment, I trigger automatically a discovery process. And part of this discovery process is looking for files that has been changed. And then the second part is then building up this graph again. But as you can see here, it notified that a new file, a new jar file has been deployed. And that's basically the application that I was deploying during my deployment. Now, as you can see, the time from the deployment matches with the time that the alert arrives, more or less. As you can see, it's about 20 minutes later. So I know there was a change. And now I like to troubleshoot. So what I can do now is go to the changes and open this change, because this is the change that is basically associated with the file that has been changed. And then go in here, open the change, and then it will have all the details about this change. So now I can even go back to the developer and say, hey, I can see that there's a correlation between high CPU of my application and your change that you have done automatically. So, please start troubleshooting. The only thing that the developer has to do is to go to his commit and look at the particular part of his code that has been changed and see if that's created that alert that was sent from the monitoring tools. So as you can see, there's a lot of correlation between what I have deployed, right? Which is this jar file. This is my Kafka client. Remember, I have two applications that I'm deploying. I'm deploying the Kafka client, which runs on the VM, and I'm deploying the website, which runs on the Tomcat server. So in this case, this is the Kafka client, which connects to the Kafka broker, but the Kafka client is spinning around the CPU. So maybe because of code changes that the developer has done, right? So in this, basically, you cannot associate the alerts with the changes, right? And all the information to troubleshoot is basically here. So you can, based on this timeline, you can make the correlation between the file modified, the change has been created, and the alert coming in. And of course, if there are incidents created automatically, then I can see also the incident ticket. So this, of course, will help you to speed up the troubleshooting. So first I can deploy very fast, but I can also react very fast if I have some issues. Now let's wrap up what we have seen in this demo. So this is the full picture. And as I mentioned, I have bring a lot of modules from ServiceNow into this demo. So we have seen item health and item visibility. We have seen GRC with its controls. We have seen DevOps with its change automation. We have seen Swiggle with its configuration management and validate against configuration files. So different modules working together to make sure that deployments that we like to do today automatically can be done automatically. Because normally when people say about pipelines, they talk only about this thing, but they forgot those things that are basically very important to make sure that, to minimize the risk and to speed up the process. Because if we don't have this in place, people still has to raise manually their change requests, maybe has to do some controls that they have to fulfill before it starts deployment and so on. So now we have everything in one tool chain. So we have the code tool chain, and this is what I call the governance tool chain that's in place to make sure that everything works together in an automated way. And again, developer doesn't have to go this side here. It can still work in his own environment. We have seen the change manager, we have seen the application support, all working in the tools of choice, so that that everybody can see if something happened in the system or something has changed in the system or the infrastructure, that they can basically trace it back to the original starting point. Before I close, of course, having all this data on the platform, we can also summarize it in a nice dashboard, which is available with the DevOps module, where we can bring all this data together and have a good overview of our performance, of our deployments, commits, and so on. And we can even associate it with things like from ITSM, from change accelerations, the system health, stability, and so on. So we also can bring this data together in a dashboard.
Thank you very much, Dennis, and thank you, Dimitri. We hope this demo brought you some lights on how we manage an end-to-end infrastructure as code in ServiceNow. Have a nice day.
Thank you.
Thank you.
Bye.
Bye.